Hello there, and today we're going to look at organic chemistry. We're going to look at introduction to organic chemistry. I'm going to tell you all that you need to know about organic chemistry. Now, organic chemistry is defined as the chemistry of carbon compounds. Carbon compounds. This is very important. Organic chemistry is defined as the chemistry of carbon compounds with exception. That means not including oxides. All right, carbon oxide, CO2, carbonate, CaCO3, bicarbonates, sulfides, and carbides. All right. So organic chemistry is defined as the chemistry of carbon compounds with exception. That means not including oxides, carbonates, bicarbonates, sulfides like this, and carbides like this. Now, they said all organic compounds must contain carbon as the most important element. So it tells you that the most important element in organic compounds are carbon elements. All right. So all organic compounds must contain carbon as the most important element. Now the next one says other elements commonly present include hydrogen. Now hydrogen can be included in an organic compound. Oxygen can be included, nitrogen, halogens, and metals, etc. But one of the most dominating elements in organic compounds are more of carbons. Hydrogens, oxygen, nitrogen, halogens, metals could just be substitutes, but you will find more of carbon elements in organic compounds. Now, let's look at the uniqueness of carbon. Let's see what makes carbon the most dominant element in organic compounds. Now, I say uniqueness of carbon. Carbon atoms has the exceptional ability to catenate, meaning to form long chains. I said catenation, all right, is the ability for carbon to combine with itself to form straight chain, branch chains, or ring compound. For example, look at this. All right, this is catenation because this is forming straight chains. All right, it can also form branch chain because these are carbon elements, and also it can also form a ring compound. All right, so this is a what? This is a straight chain, this is a branch chain, and this is a ring compound. So carbon has the ability to catenate. And what is catenation? Catenation is the ability for carbon to combine with itself to form straight chains, branch chains, or ring chains. All right, or ring compounds. Sorry. Now let's look at the second uniqueness of carbon. Carbon has the ability to form single, double, and triple bond. All right, single, double, and triple bond. For instance, if I draw something like this, all right, this is single bond, all right, because this is just single bond, all right, single bond. Now, but if you look at this, you see that this is a double bond, all right, this is a double bond, this is a triple bond, or you can also have your triple bond like that. So carbon has the ability to form single bond, double bond, and triple bonds. Now, let's look at another uniqueness of carbon. Said due to electronegativity of carbon, it can easily combine with elements of high electronegativity, e.g. nitrogen, oxygen, halogens. It can also combine with hydrogen. All right, it can also combine with hydrogen. Now the fourth one says different arrangements of the same atoms within a molecule produces a variety of compounds. All right, carbon has the ability to be arranged in different forms. All right, so it says different arrangement of the same atoms within a molecule produce a variety of compounds. That's when you talk about isomerism. Okay, when we're going to we're going to molecular series and some other things like that. You're going to, as we go on, you see how carbon can be arranged in different ways and then form variety of compounds. All right, now we're going to look at the unique characteristics of organic compounds. So now let's look at the uniqueness of organic compounds. Now organic compounds are generally soluble in non-polar solvents like benzene or ether. Take note of that. Now the next one says they are insoluble in water with exception to special groups of organic compound having hydroxyl group OH. Take note of that too, which contains hydrogen bond resulting in the solubility of such compounds, e.g. glucose, ethanol. Alright, so these are the alkanol groups. The alkanol groups have a special functional group, OH, that's the hydroxyl group. Now in our next video, we'll be talking about functional groups, which is very, very important if you want to get a full comprehensive understanding of organic compounds. So now the next one says they are mainly covalent in nature. The solubility of organic compound is due to their strong carbon to carbon bonds. And one thing you have to know is that this covalency in their nature makes them a non-conductor of electricity. Because of the covalency in their nature, it makes them a non-conductor of electricity. Alright? Now the next one says, number 4, majority of organic compounds are non-polar, except compounds such as chlorine, which is electronegative, or those consisting of hydroxyl. Now the next one says, most organic compounds are inflammable and burn exothermically in abundant supply of air to yield carbon dioxide and water. Please take note of that. Chemical reactions involving organic compounds are much slower than ionic reactions in organic chemistry. Chemical reactions involving organic compounds are much slower. They are much slower than ionic reaction in organic chemistry. Now the last one says they generally have low melting and boiling points when compared to inorganic compounds. They generally have low melting and boiling points when compared to inorganic compounds. So you have to know these two. These are unique properties, or this is the uniqueness of organic compounds. So if you want to have a good understanding, you have to know this. Now you can take the video back and write down these points so that you study them better and you make more research on them. Like I said, in our next video, we'll be looking at functional groups of organic compounds. Make sure you like this video, share this video, and hit the subscribe button so when I upload more videos like this, you get notified.